Hey, how's it going, everybody? Victor here, and tonight we'll try to go over some of the basic concepts in quality of service, or at least for Cisco. And this video will go with my latest post here on fireprotocol.com on quality of service. So I guess the purpose of this video is to I'm gonna be very brief, and it's the purpose is to kind of reference to this post right here. So we'll be touching some very specific things here, or at least the most common scenarios or the most common things that you run into when doing quality of service. So let's take a look, and this is our current setup for tonight. We have 3 CSR 1000 Vs that I don't really think we're gonna be using all of them anyways, but and we also have 2 traffic generators here. And if you don't know how to set this up, I suggest you go to this unetlab guy's unetlab guy. He made a video on how to set the Ostinator, which is pretty good and it's very straightforward. So you can look that up. And let's take a look at the blueprint here. And this is what Cisco wants us to know as far as quality of service for the CCIE routing and switching. So QoS and DHCP mapping, or basically remarking with DHCP codes, classification, and bar, which is basically classifying traffic based on layer 7, marking using IP precedence and DHCP, QoS, ECN. The difference between IP precedence and DHCP, they're pretty much the same. It's just that DHCP allows for more granularity, so you get to have, I believe it's 6 bits, and in IP precedence you have 3 bits to play with, so you get more granular with DHCP. So basically you can have more classes of traffic flows, or you could at least give them, you have more different priorities for the traffic basically. So in policing and shaping, most of the times policing is going to be used inbound and shaping is going to be used outbound. Shaping is only allowed to be used outbound, but you can do policing both ways. But you'll find most cases this will be something that's going to be applied inbound in an interface. So congestion management, which is bandwidth allocation or priority, basically saying, hey, I want for this traffic flow, I want or this quality of service group, and we'll briefly talk about that. For this traffic flow or quality of service group, I wanna allow this much, I want to set this threshold, so until this point you'll get this priority. After that, I'll just give you, if you try to exceed that bandwidth, I'll just give you first in first out behavior. Or maybe I just want to allocate this much bandwidth to this type of traffic. We also have congestion avoidance, which is a random early detection, or basically saying, hey, I want to, instead of just dropping all the TCP traffic and making the TCP sessions have to sync up all at the same time, we're going to randomly drop this. So in order to avoid a very common issue known as the tooth saw, or that's called TCP Global Synchronization. If you look at the images, this is basically what we're trying to avoid here. This behavior right here of having all the TCP sessions synchronized at the same time. So if we go back to our topology and bring up our security, we can see the Ostinato file, which is our traffic, one of the traffic generators, is gonna be, and this is all connected to my home subnet here, the 10.0.0.0/24, and that's I changed my addressing in case you noticed. I got rid of my 2821 router, which was very loud. I didn't get rid of it, I still have it there, but I'm using my SRX 100 now. I got myself a Juniper box. So as you can see, we have OSPF adjacency with CSR2 and cross this link, and we've advertised all the loopbacks here, so we can go from our generator here and ping routers to loopback. Alright, so before anything, let's do a packet capture here on gig 3 and resume our ping. Wait for it. Alright, and as you can see, the ICMP packets are coming in with DHCP value of 0, which is same as IP precedence 0, so basically no priority. This is a very useful table. Gives you the comparison between DHCP and IP precedence. So this would be the best ever class, or 0. So let's we can change that. Let's go to CSR1 and oops. And we're gonna create a class map matching any call match all and exit and create a policy map called Remark all. Now that I think about this, we didn't even need to create that class map, because we can just do class default, and you would be saying, hey, I wanna match from anything. The class default will just catch everything. But for the sake of the example, let's just say we're gonna match on the class map called match all, which is basically matching everything. So class all. Okay, and then we're gonna remark the traffic to DHCP value of EF, or expedited forwarding, which is the highest priority. And then go to gig 3 and apply this policy map with the command service policy input, and it was called remark all. Oops, got a typo there. Okay, so if we were to look at the show run pipe section policy, this is basically what the hierarchical queuing framework is about. Basically, you have a policy map matching a class map, and then you can do whatever you want with that. So for us, for this example, we said we wanted to set the DHCP value to a different value. So, but you'll find out you can do all sorts of things. So if we were to look at the show policy map interface, you can see that we have an input policy map called remark call, which is matching on the class map called match all, which in this case is matching everything. And we are setting the QoS DHCP value to EF, or expedited forwarding. So if we were to look back on our, actually we need to run it again. So, and actually let's look on the other side of it. So gig 1 as it goes out. And resume our ping. Or is it still running? Cool. And just wait for it, and there it is. If we now look at the IP header, and we can see this is now EF for expedited forwarding. So it's basically saying, hey, I'm giving the highest priority to this type of traffic right now. So that's good. That's how basically that's how remarking works. And that's something that you would normally do on the at the access switches, because you can as you may imagine, you can picture a user trying to set their own DHCP values on their frames, the traffic that they're sending out. You don't want to trust that. So what in most of the cases you'll set a remarking as the traffic comes into your network, and then you can use that remark that you just did to set the different policies that you want. So let's exit that out here. We don't need that anymore. Stop the ping. And now let's put a policer on gig 3. And what we will do here is first we'll take out the no service policy. Oops. Remark call. And we're gonna create a policy map called police at 3 megs. So basically we're gonna say, hey, on gig 3 incoming traffic, we're only gonna allow 3 megabits per second. That's it. Everything after that, we're gonna remark it with a drop behavior. So that's the default remarking on policers. But let's take a look at that. So we're gonna say police, or actually class, and this time we're gonna use the class default, and we're gonna do police to 3 megs per second. Okay, go to interface 3 and service policy input police 3 megs. If we were to look at the policy map, show policy map interface, we can see that we now have a police 3 megs applied to the interface inbound, and the committed information rate, as we stated, is 3 megs per second. It automatically calculated for us the burst committed, which in this case is 93 kilobytes. So with this information, you can calculate the time committed, which is basically how many times this policer is going to run per interval. So and I believe the formula should be here. So basically the committed information rate is the burst committed divided by the time committed. So if from this you can see that time committed would be the committed information rate divided by the burst committed, or I'm sorry, the burst committed divided by the committed information rate. So back here, that means we're going to be allowed to burst up to 93 kilobytes per second. So knowing that, let's go to our Ostinato here, and again, you can set this up by watching the video. Actually, I'm gonna put the link on the comment. So, but for now, let's go to create a new string. Call it I don't know, just traffic, whatever. Edit the string, and this is gonna be an Ethernet 2 IPv4 untagged. The frame length, we're gonna use 1470 or 1485, whatever. And we gotta say destination, so it's gonna be the first layer 2 hub. So it was gig 3, join gig 3 address, or come on, it was address all lowercase. Okay, and the source is this one, Ethernet 1. Okay, and the IP source is this one. We're gonna send this traffic to routers 2 loopback. Okay, and to do that's 1 meg, 10 meg, 100 megs per second. You know what, this is a little too much. Let's do 10 megs per second, or no, 100. That will be faster. And this many packets. Okay, we say apply, select here, and go start. Now, if we were to look at the capture here, one. Let's see what the traffic generator is doing. So here it is, and the frame size is 1481. DHCP still CS0, which we removed that other remark call. And let's take a look at the interface here and show policy map interface. Alright, so as you can see, we already started dropping packets because we exceeded the bandwidth here. So that's pretty much how a policer would work. And again, this is something that, for instance, the service provider would put on your gateway to rate limit you when you, for instance, acquire a metro circuit, or maybe a layer 3 VPN, or whatever you may have. So what you could do here, instead of just sending blindly 10 megs per second when we're actually being rate limited to 3 megs, what you would normally do is just set up a shaper. So basically you try to normalize or shape the traffic, the amount of traffic that you're sending out to kind of match whatever your committed information rate is at the policer. So if the service provider is rate limiting you with 3 megs per second and a burst committed of 93 kilobytes, you basically want to replicate this same settings on your traffic shaper. And let's do policy map shaper 3 megs and do class default and shape average of 3 megs. That's basically what you want to do. And oops, in Geek 1, actually let's just take the policy, how was it called? Police 3 megs. Oops, gotta say, okay, and go here and service policy out shape 3 megs. Was it shaper or shaper? Okay. Alright, and if we were to look at the show policy map interface Gig 1, this time we have a queuing of a limit of 64 packets. So what this means is, should the traffic exceed 3 megs, we're gonna queue up the packets in a queue with a size of 64 packets, and we can change this using the keyword when setting the policer, the shaper. So right now, as you can see, the shaper also calculated for us the burst committed, which is a little different than what we were seeing on the policer. Previously we were seeing 134 kilobytes, or I'm sorry, this is not 93.7 kilobytes, and here this is in bits, I believe, so 12 kilobits. So basically you want to match up these two, the policer and the shaper, and that's basically how you would set up the traffic shaping and policing. The other thing that we could also do here is I think we can have them combined, and if we do a show run policy map keep doing this policy, and let's go to our shaper and do a random detect. This is basically doing the early random detection. So we can do it based on the DHCP based. That way, we instead of just randomly dropping packets, it will be weighted random early detection. So we want to enable this and do again. And this time you'll be able to see how many packets we will be dropping, if any. So as you can see, because we're shaping at 3 megs and we're sending about 100 megs per second, there's a significant amount of drops, as tail drops, as well as random drops. So that will be what the random early detection would do for us. And so the last thing that I wanted to show you for now, and let's go for this, let's go to router 3. Let's do it here. So say we wanna let's do for gig 2, and let's go to class maps. Class map match any, and we'll call match. Will be called match. I don't know. ICMP. And let's say match, and see we have a bunch of options here. We can match on the IP precedence, on the protocol, DHCP value, on a class map, so you can have class maps within class maps. You can match on an access list. So for now, let's match on protocol, and there should be an ICMP here. There it is. And exit. And let's create another one called match, I don't know, voice, and match on protocol, SIP. Okay, and let's say that router 2 is our service provider, and they're rate limiting us at I don't know, 5 megs. So we want to shape our traffic to 5 megs. So what we will do is create a policy map called shape 5 megs, and match on everything, and shape an average of 5 megs. Now after that, we'll exit out of here and create another policy map called allocations, and gonna reference the class maps that we created. So it was match ICMP, and see, we can do bandwidth allocation. So let's say that for ICMP we want for whatever reason we want to allocate 1 meg out of the 5 megs. Oops. So you can either do a percentage or you can do the actual value. So let's say percentage. We wanna allow a 10%. Or we want to guarantee a bandwidth of 10% of 5 megs, and then we're gonna match on the voice, and we want to guarantee, or actually let's do a different one. Let's do priority. So and this doesn't sound right, but this is just an example. Up to, I don't know, up to 70%, up to 70% of the bandwidth we're gonna guarantee that the traffic that is gonna be prioritized. After that, it's just gonna be first in, first out. So if we take a look at this, see what we have. Oh, I keep doing this. So we can see that we have a shaper of 5 megs on grabbing basically everything and shaping it to 5 meg rate. And then what we'll do is that going back to the shape 5 megs for class default, or okay, and then here we'll do class default. The class default we're rate limiting to 5 meg, and then now we're gonna do a service policy. So we're gonna put a policy map within the policy map, and this was, what was it called? Allocations. Okay, so if we take a look at that now, what we can see is that the policy map called allocations is within the shape 5 megs. So this is basically how you would play with the hierarchical queuing framework. Just indent the policy maps within other policy maps, and now you would apply this to gig 2 with service policy out shape 5. Okay, and if we take a look at that, let me expand this. We take a look at this, we have the policy map shaping 5 megs out of everything, so it's just gonna match on everything, 5 megs. And then after we shape the traffic, then we're gonna allocate some bandwidth to a certain type of traffic, and we're gonna prioritize the traffic flow of another type of traffic. So that's basically how you would set this up. I think this is gonna be it for now. I have noticed that I've been getting more and more followers on the channel. I do appreciate your subscription. I hope you enjoy my videos. If there's anything that you want me to go over, any technology or something that I could possibly know about, I'll be more than happy to get some content. So, but to be honest, I haven't been as focused as I would like to lately. I guess just life just happens, you know. Like I said, this was a very brief video, and I hope you've enjoyed it, and thanks for watching.